Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to my channel, welcome. I hope that by the end of this video, I'll have earned your subscription. Okay, so what I'm going to be talking about today is part 3 of my V-shaped guitar build. And specifically what I want to cover is how I design a fretboard on my computer so that I can cut it out on my CNC machine. So let's get started. Okay, in the last episode, I talked about how I start my design process using Adobe Illustrator, and I'll create a full-size, full-scale top view of the guitar. Then I can separate the different elements and use those to build my CNC files. And when I talk about breaking them out, it's the body, the neck, and the fretboard. And what you see on the screen right now is the fretboard. That's the first element that I'm going to prepare for CNC. So that's where we'll start. And what I need to do is I need to further separate the elements, because when you're carving on a CNC, you can do 3D carving or 2D carving. 3D carving means any surface that has a contour or a curve or an angle to it. 2D carving is anything that is straight down into the wood, like a hole or a pocket, that sort of thing. With a fretboard, most of it is going to be 2D carved. So what I have to do is separate those elements. And I separate those elements based on the size of the bit that I'm going to use, because the size of the bit that I would use to do the inlay is going to be a different size bit than what I use to cut the fret slots, and what I use to cut the perimeter shape is going to be different. So I want to separate those out into individual files that I can use to create separate carving operations. So I'm going to separate the perimeter shape, the inlay design, the fret slots, and then I'm going to save out a file that includes just the radius shape along with the perimeter and the shape at the top where the Floyd Rose nut is going to sit down onto the fretboard. It needs a shelf. So those elements will be separate. And then what I'm going to do is I'm going to bring those elements for the radius into my 3D program, Rhinoceros 3D, and I'm going to use that to create a 3D model of the fretboard radius. And I need that just to do the 3D carving for that contour curved surface. Another important thing I should mention is whenever I create these files in Adobe Illustrator, I make sure that the document that I set them up on is sized exactly to what my blank is going to be. So in the case of this fretboard, it's 3.5 inches wide, 22 inches tall, which is the exact size of my blank. And for the neck, it's going to be like 5 inches wide, 30 inches long. And for the body, it's 18 inches wide and 22 inches long. So I'll set up the document to be those exact sizes. And then I will draw a box that's also the size of the blank that is centered on that document. That way I can make sure all the elements, when they are imported into different programs, whether I'm building the 3D models for 3D carving or bringing the SVG files into easel for 2D carving, everything is always going to be centered and lined up correctly. So that way I can do some of the carving operations as 3D carving operations and other operations as 2D, but I can be assured that everything is going to line up correctly when I go to carve them on the CNC machine. Once I've created all those files from Adobe Illustrator for the fretboard, I need to build a 3D model of the fretboard's radius, and that's because the radius is going to be carved using a 3D strategy. So what I'll do is I'll just bring the files that I created, or the file that I created in Illustrator, into Rhinoceros 3D. And then I'll use those elements to build the 3D model. Now, I'm not going to explain in detail all the different commands and such that I use to create that file, but you can probably understand what I'm doing just by watching this video. So I'm just going to play some music, and in a few minutes I'll be back. what I'm about to do now is shift gears, and I'm going to go from the computer-aided design process, or CAD, over to the computer-aided manufacturing process, or CAM. And what I'm going to do is I'm going to bring that 3D model that I just created in Rhinoceros 3D into MeshCam. And if you watch closely, when I finished up that creating that 3D file, I exported it as an STL. And STL, which is stereolithograph, is the format which MeshCam reads when bringing a file in to establish the toolpaths. And STL is really popular in the CNC world as well as 3D printing. So I'm going to bring that file into MeshCam and assign the toolpaths. Now, this is a process that could change in the not too distant future. In fact, that's one of the realities of computer-aided design. As new technologies are developed, you're having to constantly reevaluate your processes because there are new formats and those new formats have new capabilities. I know, for example, that Easel Pro, I can now import my STL files into Easel Pro and assign the toolpaths right there. But I just haven't had a chance to really play with that yet. So I have to go with what I'm comfortable with, which right now is MeshCam. But I am pretty confident that in the not too distant future, I'll probably move from MeshCam over to just doing it all in Easel Pro. But for now, we're going to jump into MeshCam. Whenever you use CNC technology to cut parts for a guitar, you have to go through the CAM process, computer-aided manufacturing. And for me, that process can be divided into two separate stages. The first stage is to establish the toolpaths and write the G-code. And then the second phase is to organize all that information and then send it to the CNC machine. Now, ideally, you want to be able to use one software program to do that. And what you see on the screen here is Easel Pro, and Easel Pro has the capability of doing that. However, some of that capability has only recently been added to the program. In the past, when I would set up my 3D carving operations, I would use MeshCam. I would bring my 3D model as an STL file in the Meshcam, which I showed you earlier when I did the radius for the fretboard. And then I would establish the tool paths, write the G code, and then I would I would import that G code into Easel Pro. Now, the current version of Easel Pro, as I'm shooting this video, gives you the opportunity to bring your STL files right into Easel Pro and set up the tool paths in Easel Pro. So I could potentially stop using Meshcam. And my plan is to do that. However, I haven't gotten there quite yet. I do most of my work on a Macintosh, and I've run into a couple of issues that I need to resolve before I can make the switch to doing all my cam in Easel Pro. But for now, I'm still going to be using Meshcam. So in the future, I hope to be making that switch over because it would be just so much easier and quicker to do it. But in order to understand my cam process, I want to take a step back to when I was talking about how I used Adobe Illustrator to lay out the design for this fretboard, because I need to reiterate a few things that I think will help make it easier to understand how I prepare and organize all these files to send to the CNC machine. And so we're going to jump back into Illustrator. And this is what the file looked like when I first created it. I set up a document that is the same size as the blank that I'm going to be cutting the fretboard out of, 3.5 inches wide, 22 inches long. And I created a bounding box the same size that is placed right over this document. It's centered on it. And the reason for that, it's extremely important. I use that bounding box as I place these files, or as I open files in different programs. I can be assured that the elements that I create for the fretboard are always going to be in the same position. And that may not make a lot of sense now, but I think it will as I go forward. But then what I did was I created the design for the fretboard, and that included the perimeter shape, the fret slots, the inlay design, the shelf for the Floyd Rose nut. And I centered that on the document. So even if I'm going to be creating the radius in a different program and then setting up my tool paths in yet another program, because I have the document set up at the same size as the blank, and because I have that bounding box, it's always going to be centered no matter what program I use. And that makes it easier to keep everything registered and in line when I go to carve it on the CNC machine. So once I had the design completely finished, I separated it out into separate files, mainly dependent upon the bit size that I'm going to be using for each cutting operation. So I'm going to be using a certain set of bits to do the inlay. So I separate the inlay out by itself and save that as an SVG file out of Illustrator. And the reason I save it as an SVG file is because that's the format that Easel Pro will read when I bring that file into the program to set up the tool paths. Then the next file that I created was for the radius. And you saw earlier how I carved that radius I created that radius using Rhinoceros 3D and then brought it into Meshcam to create the tool path. And that was only because this particular cutting operation is a 3D cutting operation, whereas the inlay is a 2D carving operation. So then the next file I saved out was just for the fret slots. And that's because I'm going to use a very small 0.024 inch diameter 2-flute spiral upcut bit to cut those slots. So I have to create a separate file for that cutting operation. And then finally, I have a cutting operation to cut the perimeter shape of the fretboard out of the blank. So this is obviously a 2D carving operation. It's probably going to be done with an 1/8 inch diameter 2-flute spiral upcut bit. And it will just take maybe a minute to cut out the finished fretboard from the blank. All right, let's jump back into Easel Pro. And what I have done is I've created my project file for this entire guitar build. And what you see at the bottom of the screen are all of the different cutting operations. They are represented as separate pages, and they are presented from left to right in the order that I will be doing those cutting operations. Now, there really isn't a set rule that you have to follow when determining what order you're going to do these cutting operations. It's kind of a process of trial and error to figure out what works best for you. What I like to do is I like to cut the fretboard first, followed by the neck, and then the body. But for each of those pieces, I have multiple carving operations, and I like to do them in a specific order. And this is something that I've kind of nailed down over the years. I'm not really going to get into the absolute specific order. I may try to, as I work through these videos on how I create these files. We'll see how that goes. But for the fretboard, which is what you see here, I have basically 4 different cutting operations. I have the inlay, the radius, the slots, and then the perimeter shape. So the first one is going to be the inlay. And that's kind of what I'm going to walk you through as I set this up so you can see how I bring my files into Easel Pro. I'll show you how I do an SVG file for the inlay, as well as how I set up the radius, which is a 3D carving operation. So the first thing I have to do is I have to create a new page to bring in that inlay. And when I create that page, I can determine the material as well as the dimensions of that document, of that file. And in this case, I'm selecting walnut. Walnut is kind of the default that I use for fretboards, either walnut or maple. I don't have a material set up specifically for the actual material I'm going to use on this guitar, which is going to be rich light. So I'm just going to use walnut. It doesn't really matter. It's mainly so that I can see what I'm doing on the screen when I'm working in Easel Pro. So I will select walnut, and then I can input the width, the length, and the thickness dimensions for the stock. And that's what you see on the screen here. So then once I have that done, I can import the SVG that I set up for the inlay. And that's what drops in when I do that import. And if you look closely, you will notice there is a bounding box. And that is the bounding box that I set up when I created the file in Illustrator. And that bounding box matches the dimensions of the blank. So everything is always going to be centered in that bounding box. That way, every element that I import for the cutting operations are always going to be very precisely positioned with regard to that bounding box. However, once I bring in the inlay, I can delete that bounding box because I don't need it anymore and I don't want to carve it. So what I can do next is select the bits that I'm going to be using. And for this particular carving operation, there's going to be 2 bits involved. The first is the main bit, which is going to cut out most of the material. And in this case, it's a 1/16 of an inch 2-flute spiral upcut bit. And then what I can do is select a detail bit, which in this case will be a 32nd of an inch 2-flute spiral upcut bit. And with those 2 bits selected, I can then determine the cut settings for that. And I always like to do my cut settings manually. So that way I can input what the feed rate, the plunge rate, the depth per pass, and the spindle speed is going to be for each bit. And that's really important because each bit has its own requirements. And so I'll set up the cutting speeds for the roughing bit as well as the detail bit. And then once I do that, you can see in the preview the cut is going all the way through the material, which of course I don't want it to do that. So what I have to do is set the cuts, the depth of cut setting, and that's going to be about 1/8 of an inch for this particular carving operation. And what you see is the pocket that's going to be cut out into the material. Now, I like to do my inlay first because I'll cut the pocket, and then once it's done, while the blank is still clamped to the CNC machine, I can fill the pocket with the material that I'm going to use for the inlay, which in this case is probably going to be some type of epoxy resin. So I'll drizzle that into the inlay, then I'll let it dry completely. Then the next carving operation is going to be to cut the radius, which is, like I said, a 3D carving operation. And what that does is it's going to not only cut the radius, but it's also going to make sure that the inlay is flush with that radius. So to do the 3D carving operation, I have to create a new document, a new page for this project. And what you see on the screen is what comes up by default, which is based on what I did just previously, which was the inlay. So it's going to be that walnut set up at 3.5 by 22 by 1/4 inch thickness. And you don't have to, you can ignore all that. It doesn't matter. The bits don't matter. The material, the dimensions, none of that matters, because I'm bringing in a previously generated G-code file that I made in Meshcam, and that G-code file has all that information already in it. So when I import the G-code file, what happens is I'll select that G-code for the radius, and it will drop in, and this is what you get. It is the tool path for that 3D carving operation. And at that point, I'm pretty much good to go. I can start, carving this G-code. I don't have to do anything else. It already knows the dimensions of the stock, the bit sizes, the feed and speeds, and all that. It's part of the G-code file. So I can just bring it into easel and keep my project nice and organized. Okay guys, well, that's all the time I've got for this episode. And if you have any comments or questions about this process, post them down in the comments section below and I'll do my best to answer them. I realize it's a pretty complicated subject and there's a lot of pieces to the puzzle. And you may think, wow, that's just way too complicated. And in truth, it may seem that way, but as you're actually doing it, once you've been through the process a couple of times, it goes pretty fast. And that's one of the reasons why I like to use CNC technology for making guitars. Once you've got it down, it goes pretty quickly. At any rate, I hope you've enjoyed this video. If so, give it a thumbs up. And if you're new to the channel, again, welcome. I hope that you'll consider subscribing. And if you'd like to help support my channel, you can always visit eguitarplans.com. There's a link in the description below to purchase plans for guitars and the tools that I use to build guitars, including a CNC machine. Or you can visit my YouTube merch shelf, which is displayed below the description for this video, and there you can purchase a lot of the same plans that I offer on eGuitar Plans, but you can also purchase a t-shirt. So until the next episode, as always, take care, stay safe, and I hope you'll be back for future episodes.